The purpose of this panel is, hello everyone. This is the Understanding and Mitigating Software Supply Chain Security Risk panel of IEEE SecDef 2021. The purpose of this panel is to put forward for the current state of the art and challenges on software supply chain security, and also to highlight future research directions for those that are interested in developing novel solutions to tackle this problematic. I am very, very humbled today to be joined by what I think are practitioners of the toughest of the tiers. They work on open source and industry doing software supply chain security. I'm going to go through the panelists alphabetically by last name, and I'm going to be talking a little bit about how they're working on securing and innovating on the software supply chain security space. I'll start with Asra Ali. She's a software engineer at Google. She has a lot of experience under her belt on FOSSing. She actually maintains some of the OSS FOSS work that many of you may be familiar with. She has done a lot of FOSSing on open source projects such as Envoy. And right now she's one of the main drivers of implementing many of the useful features of the Sixdoor project, which I think will come up during our discussion today. Asra, would you like to add anything about my introduction?
Yeah, I'll just give like a little shout out too, that I guess like I have like a special interest in like cryptographic data structures and like cryptographic innovation. And so like I love seeing where that ends up manifesting itself in like these sorts of areas, and also really any other areas. So I'll just give that a shout out.
Awesome. Yeah, I actually forgot to mention you work a lot on privacy preserving stuff as well, right? Great. Moving on to Ava Black. They are a open source rockstar, I would almost say, working on the Azure Office of the CTO. That's on Microsoft. They are involved in the OSI, the Open Source Initiative. They are the people that, they're the group that worked on essentially coining and defining open source. Ava works on many open source projects, including the Open Enclave SDK. Am I correct in saying that? They have more than 20 plus years in tech. When they are not on open source or working on Microsoft securing supply chains and confidential compute, they are also very passionate LGBT plus advocates. Did I miss anything, Ava?
I think you covered a lot. Thanks for the intro, Santiago.
It was hard to compress all of that. Moving on, I have, and I hope my alphabet doesn't fail me, Luke Hines. Luke is works on the Emerging Technologies Department of the CTO Office of Red Hat, and he works on a very, very popular trusted platform module-based system called Keyline. I like to bring it up because I think it's a very, very successful story of a paper that started in AXA 2016 as Luke would put it, a prototype from the MIT Lincoln Lab, and now it's a project that's being maintained by the Cloud Native Computing Foundation, which is one of the largest open source foundations under the Linux Foundation, which is a bigger umbrella. Luke, did I miss anything? Oh, you're the co-creator of Sixdoor, of course.
Yeah, that sounds good to me. Thanks for having me.
Fantastic. And last but not least, I have Dan, who's the other co-creator of Sixdoor. Dan is probably on, or at least owns one of the biggest tools that I use that I didn't know Dan created. If you ever used Minikube, Scaffold, or Canico, or Recore, or Cosine, Dan has to do with all of that. He's essentially a person that's very passionate about creating usable tools that can improve security and usability of future technologies. Dan is now, as of maybe a week ago, one of the CEOs of ChainGuard, which is a up-and-coming startup that's focused solely on securing the software supply chain. I think this is crucial to the panel to also see the perspective of how much opportunities for innovation and developing new technologies there are that startups are starting to prop up in the space. Dan, did I miss anything?
You were very thorough. Thank you.
Great. Okay, so let's start with position statements. I wanted everybody to spend a couple of minutes with essentially what they think the problem is, where the status of supply chain security is, and where do we go from here. I'll start just by a random call out with Ava.
Okay, put me on the spot. Sounds good. So I guess as a starting point, the old maxim about open source security that all bugs are shallow if given enough eyes has proved really untrue. Right? The volume of code is so great, there aren't enough reviewers. And it really shows that that's not an appropriate approach to how we secure this. Right? Over the last 20 years, open source has become an, if not the, established software development model around the world, especially for collaboration across companies and between countries. But a lot of the lessons learned early on haven't been replicated in the newer, younger, wonderful communities where they're prioritizing community growth, rapid adoption over security best practices. And as a result, a lot of things have become vulnerable, more so than they used to be, I'd say. And as we look at that, I think we have to consider the ways that the open source community works, both from a licensing perspective. Right? Open source is a type of software license. You mentioned my role on the OSI board. That's what we do. We approve licenses that are thereby called open source licenses, but also the values of the community. We can't compromise on the values of openness and collaboration in the name of security. There is a middle ground, and I think part of what we're here today to do is discuss how we find that.
Fantastic. I put you on the spot because I knew you would have a very, very, very interesting opening statement. Luke, do you have anything to share in your opening statement that could relate to this, or should we, go ahead with another topic that I should write down?
Yeah. I mean, Ava described it so well, the kind of the magnitude of open source that there is now, and the adoption that there is, and how the security risks have increased with that. And I think just to sort of add a cherry on top of that cake, we've, I think in a lot of ways, us folks are very fluent with modern tooling and security approaches and the kind of paradigm that we develop in nowadays. Okay, so DevOps, automation, this sort of thing. But we're very much at the forefront. A lot of folks are still trying to catch up with that. Okay, and I think in a lot of the ways, security is trying to catch up as well with the speed and volume at which development plays out nowadays. It's it's in a lot of ways, security is yet to catch up with the current sort of paradigm that we have for developing software.
That's interesting. It almost sounds reminiscent of the slow food manifesto, or the slow movement overall, trying to keep a pace in which we can ensure safety and accountability for essentially technological development. Asra?
Yeah, I just want to echo and kind of build upon some of the stuff that Ava was speaking about. And I think one thing they mentioned was the different priorities that younger open source projects have in terms of growth and adoption versus balancing that out with security best practices. And I think that's it's a big point to provide security tooling that has the right incentives for people to adopt. Is kind of low overhead, but still provides best practices and security guarantees. And that's a very difficult line to cross. And it's a hard thing to build out because sometimes those things are in conflict with each other. And I think that just goes to show that there's a lot of research opportunity in trying to find the right systems or the right data structures or the right processes behind tooling adoption and ease of use and building out that process for these younger projects to adopt things with at least minimal security guarantees.
Interesting. And I wonder how that relates to Dan's position.
Yeah, I think we jumped to open source supply chain and open source security here pretty quickly, which I think is good because I think all software supply chain is kind of open source supply chain for a couple reasons. One is that open source is in everyone's supply chain, whether they realize it or not. And two is that supply chain is fundamentally about the gaps between companies and between organizations and as things move around. So I think it's fundamentally impossible to address it without including open source. I think one of the things we just started to touch on, though, is whether open source communities and open source projects are taking security seriously enough. And I think you can kind of flip that around too and look at it the other way, which is this phenomenon we keep seeing where open source projects are just projects with a license that have been approved. Nobody has agreed to have their project used in security critical settings in a lot of these cases. Maintainers just put code on the internet with a license, and then users grab it and throw that into systems of national security or highly critical use cases. It's like nobody agreed to be a load-bearing wall in a lot of these cases, and then we start getting these new requirements and standards and practices kind of foisted on them and expectations placed on people that never really agreed to that. They just published a zip code of source on the internet. And so I think a lot of it, you kind of have to flip it around the other way too and say, are we as an industry doing enough to evaluate the projects that we're using before we use them, or are we doing enough to support the projects that we have decided are now critical without actually confirming with those maintainers ahead of time? I think there's a lot of challenges in a lot of different directions here.
I love to have to close with this, particularly because, well, first of all, it reminds me of the node event stream vulnerability. For those that don't know about it, somebody just made a very small piece of node code that ended up making it into the internal systems of the BBC and a bunch of safety critical pieces of infrastructure. I wanted to reel back a little bit, though, with the first question, and I think this will connect a couple of thoughts together, things that we have been bringing up. The question would be, from your perspective, what is the novelty of software supply chain compromises? What makes them devastating or so interesting to look at? Actually, I'll bounce it back to you, Dan.
Yeah, this is a great one. I think the novelty is a really interesting one because in a lot of ways they're not novel, right? We've known about these since the 80s and the original reflections on trusting trust paper, which scared everybody by showing how crazy deep vulnerabilities in a compromised compiler can get. But for some reason, we just kind of forgot about them for 30 more years until just recently, 35 years almost. And I think a lot of the novelty has come in just because general software security has improved so much that supply chain attacks are now one of the most attractive and easiest ways in for attackers. If you rewind 5 years ago, people were still using weak passwords. There was no two-factor authentication. HTTPS wasn't turned on everywhere. Just basic security hygiene wasn't around yet. And so supply chain attacks were there, but they weren't the easiest way. And attackers always pick the easiest way. Some of the challenges with supply chain threats, though, are that they require a little bit more patience from attackers. But once they get into a supply chain, the pivots become a lot easier. So it's a little bit harder to get in. You might not have you can't be as targeted as you meant to be, but once you attack one company, instead of kind of just ransomwaring their database or something, you can then pivot and attack all of their customers and kind of spread a lot wider. And so it's harder than a targeted attack, but the downstream effects are much more devastating as well. So I think that's one of the challenges we're all facing today.
I think I would like to bring another point, but I am not a panelist. I'm a moderator. So I wonder if Ava has anything to add.
I think Dan covered a lot of the points I would have covered. Right? We've raised the cost of entry, as it were, to compromise a company, and now open source supply chain, and many different points along that supply chain have become the weakest link in a sense. Some of my other work in the Confidential Computing Consortium is also looking at another weak link, right? In-memory attacks. We've seen a bunch of those recently, like SGX Axe and Plunder Vault, things like that. So these are highly complex attacks compared to what attackers were using 5 or 10 years ago, but they've become the low bar these days. And now we have to work to secure them.
So would it be fair to say that supply chain attacks are the next big thing, or at least in terms of compromises?
Well, we've had a lot of them, and a lot of ones that have been stopped before they were really big. But I agree with Dan that the impact of a single project being compromised can be really broad, right? Much broader than someone's account getting hacked because they had a bad password or didn't use HTTPS or the cert was expired or something. The problem is bigger.
Right. So it wouldn't be a talk about supply chain compromises without talking about SolarWinds. But I think something that's very interesting about SolarWinds is that they still don't know all of the agencies that were affected, truly. There's a list of definitely affected, a list of downloaded, but they don't know if they ran the thing, and definitely not affected because they didn't even touch the SolarWinds software. Asra, I see you nod. You have a comment on that aspect?
Well, like one thing that kind of like makes me think of, and it seems to be more and more important, is that we kind of need to have like recovery solutions because we know things will go wrong, and ways of tracking what happened a lot more robustly. So that kind of brings up that whole like, verifiable structures, like what can we like start tracking, especially because like a lot of these things, like a single compromise might, reach many points. How can we get all of those like, reachable points to kind of backtrack and say like, I was definitely relying on this, which was relying on this, and have sort of a more traceable and like, I guess, tractable way of finding out what went wrong to kind of address exactly that problem of like, okay, I don't even know how to evaluate what happened. And so having those structures in place, especially accessible to, anyone who would be affected, seems to be pretty important.
Definitely. I kind of injected that into the conversation, but I think that's also what makes them very devastating, right? Where it's very hard to measure the damage. Luke, would you agree with that?
Yeah, very much. The establishing the blast radius of these attacks, it's always difficult to do, sort of a post analysis on the extent of damage of an attack. But that is sort of, the volume is amped up even more for supply chains because of the way that these tooling and systems and that come in many guises, scripts and CI plugins, and the propagation is so wide now. Somebody can start a small project and then everybody will start to leverage that into their own project, and so I'm pretty sure. I mean, I was thinking of the CodeCov attack as well.
Right. I love
and how many folks are probably still oblivious to the fact that they were even compromised in the first place, as a result of that sort of attack type pattern. So yeah, I really agree with Asra's points, really, of being able to really establish, have assurance around being able to really scrutinize the blast radius of an attack and have confidence on at least knowing the extent of the damage, rather than a kind of a wishful cleanup process afterwards.
So for the sake of making sure that everybody knows, could any of you elaborate a little bit on the CodeCov attack and maybe a little bit of the timeline of how many times we thought we were hacked? I think, Dan, actually, you were very knowledgeable about it.
Yeah, I don't remember the timelines exactly. So if I get weeks versus months versus days wrong, please don't hold it against me. But yeah, the CodeCov incident dealt with an attack on CodeCov, which is a code coverage testing company that provides a bunch of tools for monitoring like unit test coverage of code during CI. There's a couple different ways to install it in your CI system, but one of the really convenient ones that a lot of people used was curl codecov.io/bash pipe2bash. And it's pretty magical. You just do that and it figures out what environment you're in, how to find test results, how to upload them, and all of that cool stuff. So of course that's spread pretty widely. Unfortunately, the CodeCov team had a little breach where the permissions to upload scripts to that location were compromised. I think they were left inside of a Docker image layer or something like that. An attacker found those and then used those permissions to modify that script to insert some code to export all environment variables to some IP address somewhere. It wasn't on 100% of the time. It was kind of flipped on and off just to hide itself a little bit over the period of, I want to say, a month, but it could have been shorter. It could have been longer before it was detected. In CI, a common pattern, unfortunately, is to put secrets in environment variables. And so these secrets are used things like authenticating with other CI systems or signing tools or uploading artifacts to other systems. And so this started as one compromised credential to an artifact host. And we don't know how many other credentials got stolen here. Right? Anybody that had CodeCov and ran their CI in a period of a month had to go and rotate all of their credentials. And then everybody kind of just declared mission accomplished after those credentials got rotated. But that misses the whole spread, right? What if those credentials were used to upload something to something that then got used by someone else? I think we kind of ended that prematurely and haven't really understood the downstream effects and blast radius as much as we should have. Another recent one of that same pattern was Travis CI from a couple of weeks ago, where there was a misconfiguration. I don't think it was an attack. I think it was really just a misconfiguration of the Travis CI infrastructure, which made secret environment variables available to everyone in pull requests for, again, a period of about a month. And so, yeah, a bunch of notifications have to happen. Secrets have to get revoked. Secrets have to get rotated. And that's just the first order effect. If a single other secret got stolen, now the attack repeats itself.
Pretty scary. I still remember that I actually gave a walk through the exploit for CodeCov on my last semester class, and yeah, on the security module. I think it's pretty established that the blast radius is generally devastating. They're very hard to track. They're somewhat easy to carry out. You just need to find that one entry point into the essentially infinite graph of software artifacts. This is being shared through open source and closed source. Now, this seems to be a very, very untractable problem. So I am going to put forth a question on what would be the most urgent actions, looking at them from like an industry or like general public or government perspective, to start tackling this and making this more of the problems that we think we have pretty much solved in the industry. What do we do? I'll go with you, Luke.
Yeah, I think really just the start with the basics, okay, and look at your CI system. Do some due diligence around what you're actually putting in. Okay, be aware of what you're putting in. Do you see what I mean? Take an inventory of that. If you can establish is all of this actually required, or because we're all developers, we all know how it is. You get incredibly creative with CI. You start writing your own scripts. So you'll write a bash script that passes some YAML and then passes it into JSON and then puts it over here. And we developers get really creative with CI. So I would say just, for a basic, really understand what you're ingesting, where from, okay. And then at least you have the awareness then, so that if a compromise does happen, you know which systems are leveraging the compromised code or projects. So really just be aware of your CI. And I'm going to steal a phrase from Dan here, which is I've heard Dan say before, treat your CI like it's production, because it is. It's harden your systems. Do an inventory of them, understand what they're doing effectively. Sorry, Dan, I stole your buzzwords there.
I'll actually give Dan a chance to also add, especially because I'm going to put in the hat of the Salsa project adjacent individual.
Sorry, yeah, just to kind of build on that. Yeah, it's like Luke said, I think that is the best place to start. Treat your CI system, treat your artifact managers like their production systems. We've had a nasty habit of as an industry up until now of pretending that they're not real systems and kind of being fine with running on Jenkins machines sitting under people's desks in offices when there's no way you would run production databases that way. But now it turns out that having the ability to modify code that runs next to that database is the same thing as having database permissions. So kind of need to treat those at least as securely as the production environment rather than less securely. And a lot of those principles, I guess, you're kind of poking at with the questions about SLSA. The SLSA project, slsa.dev, is around kind of defining a bunch of best practices or standards for how to operate your build pipelines and how to operate your source control systems and how to operate your deployment engines in such a way that you can kind of approach that in a set of levels, starting from SLSA level 1 and moving your way all the way up to stuff like fully reproducible hermetic builds with side provenance captured by trusted systems at every step of the way, and trying to make it more approachable and easy to understand, I guess, for people.
Tiago, I think you're muted.
Yeah.
So I was actually saying whether you had something to add, Eva, seeing that you reacted to.
Yeah. So far, folks, Luke and Dan have talked about CI systems, and that is very important. But I think I would frame it a little bit more broadly. All of our developers often pull down code from the internet, right? Obviously, you shouldn't just curl some random GitHub script and put that into your production environment, but everything you're downloading, every package you're depending on, consider why you're trusting that source for it. Is that a reliable source? Do you know who they are? Is it signed? Is it being in some way validated or authenticated in transit from whoever's responsible for building that source package or Docker image or whatever, uploading it somewhere, and then to where you're consuming it, is that entire pipeline validatable? And whether you're using a distro that does that for you, you're outsourcing the responsibility to verify and trust all of that, or doing it yourself, it's still a really critical thing to do. And that covers more than just your CI system.
Definitely, that has a hint of needing infrastructure, technological infrastructure, and computing infrastructure to do something like this.
Your question was also pretty broad, and I'd love to just put one more thought out there. I think we need to build a system or a set of tools or APIs to begin tracing in reverse for every piece of open source, every piece of software that we're using, how to know where it came from and what its constituent parts were all the way back to that initial developer. I think that's crucial to how we solve this in the long term.
I love this, and I'm going to keep it on the side. I'll bring it up in the next question. Asra, any thoughts about, say that you were involved in the OSS FOSS infrastructure, maybe you have and Sixstore infrastructure. Would you like to add anything?
Yeah, I think everyone above has said like most of what I would have said, highlighting those points about like ease of adoption and just starting from somewhere to, points that Luke and Ava both brought up about tracing where things are going wrong and having awareness of like where and what you are doing when you're building software supply chain, being aware that like it's just a recursive problem of like, you are depending on someone else's software supply chain who's depending on someone else's and so on. So having that awareness is just super critical. From other sides, I guess, your question was really broad. So I'm trying to remember what actions can people take in the wake of this urgency, I guess. Yeah, is that ease of adoption and knowing that there's tools out there that can help you start fuzzing that have like easy integrations. So OSS Fuzz, for example, or like a lot of these tools that we're starting to see build up now are sort of focused on having this like very low overhead adoption. And so just starting from somewhere is probably the most urgent, action that someone can take.
Great. Okay, so I'll move on to the next question, and I'll unwrap what Ava had just said about we need to build a system to track the sort of provenance graph of everything, and just essentially starting to define accountability and vulnerability surface assessment and so on and so forth. Now, with that in mind, the question used to be, what are the fundamental research questions to answer Is it one of systems building? Is it one of data science and data collection? Is it some, is there some cryptography baked in there? Is it a combination of all of these? Does anybody have any sort of like immediate, this is something that a researcher would definitely find interesting, try to solve on the more like scientific approach, on more purely, we need help from academics for this.
I can have a go.
Anyway, go ahead, Luke.
Yeah. So just from my own corner of the world, within the context of this area of research, supply chain, something that I'm always interested in, and I think always needs somebody to come up with something unique and different, is around the identity of machines, okay, and workloads within an ephemeral, that have an ephemeral state, effectively, you know, and especially with these layers of abstraction that we have now with hypervisors, container runtimes, varied infrastructure where some of it's on a kind of a hosting provider like a GitHub, and, you know, is really sort of being able to leverage, and it's very tricky to do, leverage a hardware root of trust. Okay, so there are technologies. We have you know, trusted execution environments, enclaves, TPMs, but sort of the level of the accessibility as a guest on the higher levels, it's very tricky to sort of to percolate that trust up, if you see what I mean, around the machines effectively. So that's probably like, that's kind of a small area, but it's something that I've always been interested in, really, is how to sort of attest things when they're ephemeral and there's several layers up the chain of abstraction from the host itself. Yeah.
I don't think I would call it a small area. It is definitely a challenge, right? Something that maybe you're dealing with in Fusio and Spire, sort of like identity providers, distributed ID, and all of that sort of stuff.
There is approach there, but you got that turtles all the way down. Eventually, you kind of you need to come down to the hardware, really, to, you know. Exactly. And how do you do that with a hosting provider? When they're not going to expose their hardware because it's, you know, it's their infrastructure. So this is all just in an area where I think it'll make some interesting research.
Ava, I know you have insight on this.
Just on that point, there's work actively being done in the IETF Remote Attestation Working Group and in the Confidential Computing Consortium to create standards, and there is still plenty of room for research in that space for how to demonstrably attest using a hardware root of trust to a different party, so that one, as a consumer of cloud or a consumer of some platform, one might not need to trust the platform provider, but could instead trust the actual hardware vendor or CPU vendor or TPM vendor. Obviously, you have to place trust somewhere, but if you can minimize the number of parties involved in the trust relationships, then at least, you know, you've reduced the attack surface some.
Definitely, I think that's a big part of the equation, and I think that some of the intrinsics may be familiar to everybody in the call and in the panel, but there's definitely something missing, right, to bridge this gap between, well, there's a bunch of semantics for hardware root of trust. How can I authenticate an ephemeral worker on the Travis CI cloud, whichever it is, to know that this produced a binary that had a bunch of downstream effects, right? Dan, I think this is something you wanted to tackle with 6.4. Do you have something to bring out there?
Yeah, I think we definitely want to get things down to hardware roots of trust. And then I guess the other area where I think research can help too is kind of around some of the privacy issues and concerns. As we start getting these attestations all the way down to specific pieces of hardware or specific individuals that touch, like, you know, multi-factor auth tokens and stuff like that, it's great for security, but it also starts creating this giant pool of data that can be used to track individuals and devices and things like that. And so I think a lot of the concerns are around how to balance those. And I think that's something the research community can help a ton in, being able to make, you know, proofs that something was in a good state without leaking information about that device that could be used to join, a pseudonymous contribution across multiple different projects where people are trying to maintain different reputations and things like that. Open source is great because people can contribute however they want to under different names and without requiring a lot of these privacy things. But unfortunately, security and privacy are often pitted against each other in a lot of these. I don't think there's anything fundamental. I think we just need to spend more time and be careful about it as we start trying to track more data and verify the attestations.
That is a great answer too. I know that Eva, yourself, you were worried about some of this when some of the ESPOM work started to surface. And that's where you also spoke about privacy preserving work. I wonder if you have any insight here too.
Yeah, this is a very good question, I think, because it's really hard to balance like how much privacy you do end up preserving if you use modern day technologies that are trying to zero knowledge prove something and not reveal what you're doing, but at the same time balancing tractability and like other sorts of things that we were talking about earlier, where it's like, okay, well, you will probably lose out on information like post compromise I guess like analysis, so I think there are pieces out there like Dan said, and it's like, yeah, maybe we just need to be more careful about it, and also have people like really take an in-depth threat analysis and like security analysis on some of these pieces of work that are starting to build out now, because I mean, in all honesty, like it's a little bit opaque to me what is actually happening when we build out these systems in the long term.
Yeah, I think there's definitely an opportunity area for us researchers to take a principle first approach rather than many of the demands that industry sometimes has to just ship it. That we can start answering questions on how do you actually measure the threat surface, or how do you understand, say, the alpha levels, how do they correlate to historical attacks. I know that there's some work in there, but maybe as academics or like security researchers, we can also bring forth a more structured approach to understand all of these variables and all of these bits and pieces, and how those interrelationships play out. I wanted to move on. I think we're on time, but I wanted to wrap at least with this question before we go into audience questions. Because I think this is also critical for people that are trying to think about funding and understanding how they can work on this space. I know that there's a lot of interest from industry in the Executive Order 14028, improving the nation's cybersecurity. This was a follow-up after SolarWinds, and I think the Colonial Pipeline. There was a call for position papers from the NIST. From NIST around actually software supply chain security innovation and how do they fulfill a particular bit of the EO. I was a little disappointed to find very little academic positions in the space. So the question would be, in your opinion, what are the opportunity areas that this call from NIST and the Executive Order themselves open for research? Do you think this would also open pathways for academics to also collaborate with industry, especially seeing that there's going to be requirements about software bill of materials, about ways to increase accountability, and more stringent supply chain requirements? Do you envision a pathway to improve collaboration between software supply chain security research and the industries that you're involved in, or maybe even, I don't know, NTIA, the National Telecommunications and Information Agency, to start bringing innovation from academic research into this space? Does anybody want to give it a go? I know it's a big question.
Sure, I'll go first. I think there's a lot of opportunity here for research, and I know there is active research in distributed identity systems, distributed key management, and zero trust with zero knowledge proof systems. I think there could be more. There's a good opportunity to intersect that with how we think about trust between humans in contextual ways, reputation on the internet, and doing all of this in ways that do not require legal name disclosure or sort of, there are plenty of demographics that are not comfortable for a number of reasons using their using their legal name in public ways on the internet. The very nature of open source is that it is open, it is public. How does that, how can that intersect as we necessarily lock down the supply chain a bit more?
It's a good point, and I wanted to bounce back. Part of my expectation as well is that this will start increasing accountability for companies that are using open source, right? They're essentially handing over open source into their consumers. So there's a definite interest for finding ways to communicate this information properly between all of the parties and essentially create accountable systems. Do you think this factors in? As in, do you think this factors into the interest from industry to do active research on space?
It does, yeah.
Anybody else has anything to add?
I think I would hope it does. Yeah, I guess. Yeah, I would hope that a lot of these, the new government regulations and standards and everything do kind of, place the burden on companies rather than on open source communities first, and force companies to be more conscious about what they're using and kind of trickle it down, I guess, rather than having regulations just thrown at random GitHub repositories and issues filed and maintainers yelled at even more than they already are. I would hope it goes the other way and starts with the people selling software to the government and figuring out ways to get them to do it correctly and better, and working with open source communities rather than just kind of throwing new requirements at them. That would be the dream scenario, I guess.
I think in essence, this also dials back to having systems to trace and understand the software supply chain provenance, so that we can actually start understanding, the implications of writing libtiff and ending up in every single thing that renders diffs, being part of like a bunch of 0 days on like some PSP and Chrome browser, and I think the Nintendo Switch had it to the first Apple click to root, browse to root was, forget, hack. All of them relied on this single library that I think the developer never thought it ended up there. Yeah, Asra, Luke, do you have any other points around this?
Not really. I just think if we sort of consider this again in the open source context, just to further what Dan said, really, which is that there can also already be quite a substantial cognitive load on open source maintainers. They're typically folks that never have a spare minute really to do anything beyond deal with a sea of issues and pull requests and so they're already under a lot of pressure. So really what the corporate world can do to help chop the wood and carry the water is the right way to look at this. It's what can, rather than sort of demand, help really.
Awesome. Asra, do you want to add something, or should we jump with
I think there's not much to add. I guess like as an open source, like having been, a maintainer of open source projects before, like these concerns, like, putting the responsibility on the maintainers is definitely not the right answer. And it's also pretty, it's pretty non-trivial, I think, even if companies decide to take ownership over building out like solutions and tools for maintainers to adopt. It also needs to kind of be in a way that's not like overstepping. You can't just like say, maintainer of this project, just go and like, add blah, blah, blah action because we need it as, a company who's consuming it. Like that's kind of like the wrong model. It should kind of be like more of a synergistic, like, symbiotic relationship here. And so kind of like as companies build out these tools, they kind of need to think about that as well.
Yeah, I wonder if there's space for innovation in identifying disincentive models. I think there's, again, probably what the CII, the Core Infrastructure Initiative, tries to get to at some point, to produce these channels of to communicate between industry and open source, and identifying how to improve practices all across the board. I'm going to leave with that thought. I see that the questions are popping up. We're 12 minutes from the close, so I really wanted to give the audience a chance to ask. The first one comes from Sunha Sethumethavan. Sorry if I pronounce it very badly. They say, as we mentioned, incentives for security, assuming that security is necessarily going to involve some friction in terms of performance, usability, deployment. I am interested in what these incentives might be. That's what the question reads. Do you think it would be measurable to try to balance this different types of incentives? The question was directed at Suresh, right? We can move on with another question, and then we come back, see if Simha wants to rephrase. They also posted the same question, a follow-up question on Ava's. So Ava mentioned promise tracking. So let us say we do this, and that we find that we accidentally introduced a bug in a package that was later exploited. What should happen next? Once we were able to track provenance and identify a compromise, and it being the cause of compromise, what should be the next steps?
Other than fixing it, of course.
Of course.
Well, we have a system, right? The common vulnerability identifiers. There's a couple systems for sharing information about that when a package or piece of software has been found vulnerable, to notify people. But it's in all of our current systems, and I don't have a great solution that changes this. It's up to those who are consuming the software to also be monitoring the feeds of both that software that they're consuming, if they disclose a vulnerability, or sort of the common feeds, and then recognize that and fix that downstream. I think there is room to innovate how we identify that in things that are, I guess, compiled in maybe your second or fifth order dependencies are less visible today. And that's where we can improve things with traceability, right?
Yeah, I want to piggyback on that. And I think something that you may want to bring up was CVEs, right? You can assign a CVE to it and just try to communicate this information. But we see that this is also somewhat lacking, right? There's an intrinsic limitation of, say, CPEs that say they apply to all of this. The CVE applies to all of this family of artifacts, but sometimes there's not a clear delineation between this is a vulnerability that applied on the source code that was later compiled, eventually made it down, or is this a vulnerability in the particular way that the compilation flags were applied to this version of the source code, or this is a vulnerability on a configuration file as it was applied to this particular instance of the source code compiled and packaged with this Linux distro. Am I good in adding that to some of the causes for or the requirements for innovation?
That's a great summary of the complexity here and where CVEs as we use them today are insufficient. I know folks like Alan and a bunch of the folks on this call have all been talking about how to improve that. I think it's a good space for innovation or research.
Great. So I see Ethan Johnson's typing. We have 9 minutes. Well, Ethan is typing. I'll throw in another question from us. I don't see him rephrase. So a question that I had is, what is your recommendation on workforce training or development in response to supply chain compromises? I assume that there is a lack of experienced professionals that understand this problematic and that are able to deploy systems or even be first responders to I don't know, handle a security incident on an open source project or verify that it was patched on the infrastructure. What do you envision us as academics that are also training people for future jobs we could start introducing in modules in our coursework to essentially change this fact?
I think this is like just like a, I'm just throwing stuff out right now. But I think it would be like, if I were in their shoes at this time, it would be really cool for me to have a sort of like a workable understanding from the opposite side as like an attacker on an open source project, and then work backwards to kind of figure out like what are the easiest ways to sort of mitigate that. And then I could imagine like if I was, going into the workforce like 2 or 3 years later, like I'd have a much more solid understanding of like how easy it is sometimes to make those attacks happen in practice. Like we know that they are easy, but like it would be really cool to have like sort of like younger people coming out of the academic environment with like very practical knowledge of that sort of thing.
Right. Yeah, this is something that I tried to underline on my course last semester of like, for example, showing the code vulnerability and how easy it was to essentially get the keys to the kingdom. Ava, you wanted to add something?
Yeah, I would love to add to that and say, I think there's a real opportunity in academia to teach about open source community, open source development practices, both the history of how open source came to be and why it has been so impactful across the world. And that's a great context from which to help people sort of step into what Asra was just describing, like how do you attack an open source project, and therefore how do you secure it? But not just, I would say don't start there, but start with what is open source? Why is it so prevalent, so widespread, and so powerful as a tool for development today?
Right. Yeah, and I think that's something that we're doing at a service to students, that some of them don't understand packaging or how to actually do everything that's around the source code they're creating. How do they distribute it to other people? And at the same time, how do they use open source in a safe way? Am I right in adding that?
I would go a step further. I think you're describing the what, or the how of what is open source, how do you use it? I'm talking more about the why. How did it come to be? What are the principles behind it? Why are these licenses or the 10 principles of the open source definition? Why have they transformed the way we build software over the past 23 years?
Wow, okay. Yes, I also saw the question from Ethan, and now I realize how much there is to ask. I'll try to split it out, considering we have 5 minutes. You can always follow up on Slack. So I think the top level question is, what are your thoughts of anybody on the panel on using more containment-based solutions? I imagine sandboxing or minimizing blast radius to other supply chain security rather than reputation-based systems like tracking provenance, understanding where things come from, that the world largely relies today and have frequently proved inadequate. Ava, I think you had a reaction there.
Yeah, I've been doing a lot of work in the trusted execution environment or enclave space. I think Luke's has focused more on hardware root of trust, which is parallel but distinct. When you say containerization or isolation techniques, I think, okay, well, what's the next thing after VMs and containers? It's enclaves. And I think that tries to address the problem from the wrong angle. That looks at lateral movement. If one component is compromised, how do you prevent attacks against other components in an environment or across a cloud provider? What supply chain attacks have shown us is it's not lateral, but deep. One compromise can roll out, and to Dan's point earlier, once that supply chain compromise has been used, it can then propagate into entirely different systems, not by breaking out of a container or a VM or an enclave, but by stealing credentials or poisoning another component that is following all of the appropriate channels to then poison some other environment.
Right. This reminds me of the Aurora compromise, right? In which they essentially broke into some web server that they knew that a bunch of people in the US government and Google were using, and then just chained a bunch of compromises to eventually steal Google's source code, if I recall correctly, among other things, right? So we are 3 minutes away. There's a big question on the Slack that I'll also at least I'll make sure to get it to you via DMs on multiple flags in case you're not on Slack there, just to try to get some answers from you. But using the 2 minutes we have left, I wonder if there's any closing statements I would want to do. Anybody wants to go first? Okay, Dan, you haven't spoken in a little bit.
No, I don't think I have anything super profound to say at the end here. I think we covered a lot of great topics. And yeah, thanks for having us. The best thing is just to keep talking about these and not forget about them, because the attackers aren't going to, I guess.
That's pretty true. I think then we could close it out now. I'm sorry, Ethan, your question is a little bit too long. I'm afraid of reading it will take me probably the last 2 minutes we have. I'll make sure to get it to the panelists. And well, with that, we're done. Thank you so much. It was a pleasure. I really enjoyed this conversation. And thank you for your time. And I hope it was equally enjoyable for you.
Thank you so much.
Thanks so much for having us.